All right. Good evening, everyone. It's a pleasure to have us again today. My name is Johnson Wall, as we know. So just like our culture has been, we'll start with brief presentation. So after the presentation, we open the floor for us to share our knowledge and experience on this topic. So today we are looking at confined space entering. So we'll be focusing on the risk management of confined space entry. So let's begin. So first, let's look at the major element or what makes a particular space a confined space. There are three major criteria that every space that's considered as a confined space must meet. The first one is that that particular space is large enough and is configured to allow an employee to enter and perform a particular assigned task. So if that space is large enough and is able to allow somebody to go in to do his task, it has met one of the criteria to be termed a confined space. The second criteria is that it will have a limited opening for entry and exit. So that particular space or that particular environment or that particular place has limited space to allow entry and exit into the place. So that is the second criteria that will make it to be acceptable as a confined space. And the third one is that it is not designed for continuous occupancy, meaning it's not designed that the worker will stay in that location for a very long time. So these three criteria are the major factors that will be considered before you classify a particular space as a confined space. The place will be free, it will be open enough for somebody to go in, and it will have a limited entry and exit point, and that place is not designed for continuous entry. It's not designed for continuous occupancy for you to stay there for a long time. So when these three criteria are met, then we'll say that space is confined space. So you can't just define confined space without considering these three criteria or these three major factors. So typical examples of confined space can be seen in different sectors, different industries. You have fuel tanks, fuel storage tanks is classified as a confined space because you can see it's entirely closed, but it still has some exit and entry points. The silos, you see how enclosed it is, but it still has entry and exit points. So the water drains is also considered as a confined space because of meeting these criteria. Then the chemical storage tanks, the shipping storage iron ores, the water pipes, these big hydropower generator water pipes, then the sewer, the manhole, trench. So any space that meets the three major criteria of a confined space, we'll refer them as confined space. In different industries, we'll see them. In high-rise building, we'll see them in shafts. You see those shafts that they are very limited, they have very limited entry and exit points, and they are not designed for people to stay there for a long time. So those are typical examples of confined space. So let's talk more about those criteria. The first one is limited entry and exit. So we say that the hole or the entry point is as small as 18 inches in diameter. The size of that exit and entry point is as small as 18 inches. And there is difficulty in entering if you have your life-saving equipment attached to you. So there is difficulty in entering because of the size of that entry point. And the entry point, there could be difficulty in removing any worker who is folded up in that space. And the exit point is from large opening may be difficult due to ladders and other things. So this is one of the criteria that will help you to define that this place is a confined space. Because in some instances in the workplace, you might identify a particular location as a confined space and people argue with you. They will argue that this is not a confined space. So these are some of the criteria, some of the factors that we need to look into to actually define or identify a particular confined space. Now, that place has an unfavorable natural ventilation. So when there is lack of air movement in and out of that atmosphere, either there are deadly gases that are trapped inside, or maybe there are other organic matters that have decomposed inside, or maybe the oxygen inside the confined space is not sufficient. So that brings about unfavorable natural ventilation in the confined space. Now, so how do you define an area that is not designed for continuous occupancy? It means that there are other things that are occupying that location in the confined space. So not just because the place is very small, no, it might have a limited entry point, but inside it is wide enough. But being wide enough does not mean that the worker has the liberty of staying there for a very long time. Now, these other criteria will help you to identify that this is actually a confined space. It is not designed for continuous occupancy of the worker because there are other products stored inside that location, or maybe there are other items that are designed to stay there for a very long time. Let's take, for instance, the underground metro tunnels, okay? It has a very limited entry point. We have shafts that were designed during the construction to enter inside the metro tunnels. But when you're already inside that metro tunnel tracks, you see that it's very large enough that if you decide to stay there, you can stay there for a very long time. But it is not designed for human beings to stay there for a long time because it is a transportation route for the train, right? So that particular reason makes it a confined space. Even though that inside of it is very large enough that if you stay there, you will nothing will happen to you. But because it's not designed for you to stay there for a long time, it's designed for other purpose, either for storage of items or either for inspections or just for materials to be stored. So because there is other purpose why that space is meant for, then it is not designed for continuous worker occupancy. And it is also one of the criteria why we can say that this is a confined space. Not just because it's very small inside. The entry point could be small, but the inside of it might not be small. So people will now argue that when you enter inside the tank is very wide. So it's not a confined space. No, look at the entry point. The entry point is very narrow. So that is one of the criteria that make it a confined space. Now, when you get inside it, even though that is very large enough, but because it's not designed for human beings to stay there for a long time, and it has other purpose, which is part of maybe storage, maybe for movement, maybe for just inspection. So there is a defined purpose for that particular location. So it is definitely a confined space because it's not for workers to stay there for a long time. So let's look at some of the obvious hazards that are associated with confined space or that are inside a confined space. So the first one is oxygen deficiency. Oxygen deficiency is a situation whereby the oxygen level in that confined space is not enough, it's insufficient. Oxygen-enriched atmosphere is in a situation whereby the oxygen level in that confined space is above the normal air oxygen level. Flammable atmosphere, toxic atmosphere, extreme temperature, where there's engulfment hazards, noise. So we'll look at some of these hazards one after the other. So how do we say that an environment or a confined space is oxygen deficient? In a situation whereby the oxygen level in that environment is below the 19.5%, which is the normal acceptable oxygen level in an airy environment. So in the confined space, when you measure it and you find out that the oxygen level is below 19.5%, then you are approaching oxygen deficient environment. Now, at each of the levels, there is an expected outcome or expected consequence. The first one is when the oxygen level is between 15 to 19%, it's expected that the worker will experience decreased ability to do strenuous activities. He will start feeling a bit weak. When it's between 12 to 14%, then the worker will experience poor judgment, respiration increase. So he'll start breathing a bit faster. Then when it's between 10 to 12%, the respiration increases faster also, and there will be, the lips will turn blue. Then between 8 to 10%, the worker could experience mental failure. He could also faint, he could become unconscious, he could start vomiting. Then between 6 to 8%, the worker could possibly die between 4 to 5 minutes of being exposed to that 6 to 8% of oxygen level. Then between 4 to 6% of oxygen level, the worker could enter coma and could die in 4 seconds. So this is a typical scenario of what happens in an oxygen deficient atmosphere, typically in a confined space. Now, the other one is oxygen-enriched environment. So which happens mostly in confined space, especially when there are activities going on in the environment which contributes to the oxygen level in that environment. So when the oxygen level becomes above 21%, so you start experiencing, you start having that suspicion of oxygen-enriched environment. So immediately it gets above 23.5% of oxygen level, then there could be fire. The oxygen is well enriched that the slightest ignition source could cause fire in that environment. So this environment is known as oxygen-enriched atmosphere, which is always supposed to be avoided in every confined space. That is why continuous monitoring is recommended while confined space is going on, continuous gas monitoring. So another hazard associated with confined space is the toxic environment. Because of the products, maybe the products stored in the environment, or maybe because of the activities being carried out inside the environment. So maybe gases released during cleaning, or maybe during forging inside the confined space, or some gases also absorb into the walls of the confined space, or maybe decomposed matters or decomposed materials inside the confined space, forming a toxic environment. Other activities such as welding, cutting, brazing, soldering, these activities could introduce additional toxic substances into the confined space. Also painting, sealing, bonding, use of chemicals could then introduce additional hazard and additional toxic environment into the confined space. Extreme temperatures, this is another hazard associated with confined space entering and activity. It could be extreme hot or it could be extreme low, depending on the environment, depending on the location, and depending on the depth of that confined space. Or maybe also depending on the storage area. Maybe the confined space is used for storage of cold items. So it could decrease the temperature of that particular place. So in hot areas, it could be extremely hot. In cold environment, it could be extremely cold. So this is one of the hazards that is also associated with confined space. Engulfment hazard. This happened in a situation whereby there are loose materials inside the confined space, and unknowingly to the worker, he walks into it and he's trapped, such as grains, sand, loose soil. So the worker could be trapped inside those loose materials and cannot easily get out. So we said this is an engulfment, and it happens most often inside confined space, maybe inside the sewers, inside the manholes, where water is moving through. So this is one of the hazards associated with confined space entry. Now, to identify this, the type of environment, to identify the oxygen level of the inside the confined space, or either toxic gases are present or not, we need to conduct gas testing. So atmospheric testing or atmospheric testing is one of the requirements or one of the criteria to ensure that the confined space is safe before entering, during entering, and even while the activities is going on. So to conduct atmospheric gas testing, it's required that the testing should be done in three major parts: the top of that confined space, the middle, and the bottom. Okay. Then the reason is that some of the gases or some of the substances are lighter than air, which means they could float on the air. Some are heavier than air, which means they will sink below the air. So you need to conduct this gas testing at different levels of that confined space so that you'll be able to identify which the gas that is present in any of those locations. Then the gas test should be done by trained authorized gas tester using equipment that is, or gas testing equipment that is that has been calibrated. So ventilation is one of the key control measures that need to be adequately provided while working inside a confined space. Now, ventilation inside confined space is different from ventilation in a normal environment where there is where air movement is freely without restriction. But inside the confined space, there's restriction of air movement. So that is why there is a proper ventilation machine that should be used for confined space activities. And it should be positioned in such a way that the air will be going inside and there will be also air coming outside. So the machine sucks in the maybe contaminated air to the outside atmosphere, then send in fresh air inside the confined space. So ventilation inside the confined space is should be continuous throughout the activity. It should not be just maybe before the start of the activity, but throughout the period that the worker is inside the confined space. Now, respirators. Respirators play a very crucial role while people are inside the confined space because it protects them from these toxic gases. It helps to filter dangerous substances from the air so that the worker will not be breathing in all the toxic substances that is available inside the confined space. So respirators helps to filter dangerous substances from the air, allowing the worker to breathe in fresh air. And the respirators are also not permitted to be used in an oxygen deficient environment. Okay, then there are air supplying ventilators. Air supplying ventilators are used to deliver or supply sufficient breathing air from the tank that is suspended on the worker's back or maybe the waist. Okay, so this is air supplying ventilators, but air purifying ventilators helps to filter dangerous air from the dangerous substances from the air. And that is the one that it should not be used when there is insufficient oxygen in that environment. Now, another control measure that is very crucial in confined space activity is permit to work. We all know what permit to work is. Permit to work helps you to control that activity, ensuring that all adequate control measures has been put in place before that job is authorized or before entering into that confined space is authorized. So permit to work must be written by the entry supervisor, and it should be verified, who will verify all the control measures that are in place, ensuring that everything is safe before entry is allowed. Then if the permit is approved, the permit should be posted at the entry point of that confined space. Then the permit should specify the hazards associated in that location, the oxygen level that has been identified, the toxic, the gases that has been identified, and if the job is completed, then the entry supervisor would close the permit. The date, the location, and the name of the confined space must be contained in that confined space permit. Then the duration of that job will be clearly stated in the permit before it will be approved. Then the authorized entrants, the attendant, and the supervisors, the names will be included in the confined space entering log sheet. And all the adequate personal protective equipment must be available and identified before the permit will be signed. Then the permit will be issued by the authorized persons, signing the signatures, and after confirming that the gas testing or atmospheric testing has been conducted with ventilation available, isolation, removing all the energy sources from the confined space, flushing has been done where required, and if logout tagout is required, if there is any energized energy source in the confined space, that it has been logged out and tagged out before that permit is approved. So for every confined space entering, there should be a rescue team available, because if something happens, there should be adequate and swift rescue of the confined space entrant. So the name, the contact details of the rescue persons must be posted near the confined space so that the whole watcher can be able to contact them immediately while they, if there is an emergency. And standby rescue team will be available at any of the confined space entry points to ensure that rescue is conducted immediately when there is need. So training, before any worker is allowed to work inside the confined space, he's supposed to attend proper confined space entering training, which will educate him on the hazards and the risk associated with confined space, and ensure that he understands the entry procedures, he understands the emergency evacuation procedure before he's allowed to walk inside the confined space. So training is a mandatory requirement for all confined space entrants. Okay, so this is the end of my presentation, because I need to give room for others to also contribute something. So thank you for listening, and you can go ahead and share your opinion now. Mr. David, go ahead.
Good evening, all. It's been long. I actually attended the interactive session due to my timing. Even now, I'm currently at work. Just have to go to a side and then join the interactive session. This topic actually reminds me of an incident that happened here in the state of Qatar some time ago, involving a big contractor, which we all know about. For some reasons, we'll not mention the name. So, work in confined space, often neglected by some small companies. But the companies that have seen the consequences of non-compliance to the precautions have taken it very, very seriously, to the point that they are willing to take extra days just to get all the requirements in place. So it so happened that in this particular work, this is actually a tunnel. They are into road construction, and then the works in the tunnel proceeded with people carrying out several activities in that shift. So it so happened that a fire broke out and engulfed everyone inside the tunnel. There was not a single soul that survived that. It was actually a big loss, and also a damage to the company reputation. So during investigation of what happened, it was reported that they were carrying out hot works, and there were some flammable items inside the confined space used for some other works, maybe for cladding, or I don't know what exactly they are doing. So the fumes which generated from those flammable items kind of saturated the whole of the tunnel. And when it got to a certain point, it actually caught fire. So there was no way. The fire started from the entrance of the tunnel. So no one was able to come out. No one. So this comes a lot to tell us about the importance of housekeeping, proper planning, and especially gas monitoring when working inside confined space. It's actually it always drops tears whenever I think of remember such scenario and that incident that happened. So it's a learning point for other people, big loss to the family, a learning point for we that want to move forward and apply this in our different departments and different fields. So confined space is actually one of the most delicate areas to work in the industry. When in construction, in the oil and gas, it's actually one of the most delicate areas. So I would say this topic is kind of a refresher for us to be mindful of the steps to take for works in confined space. I'm really glad to be here once again, and I welcome and thank all of you for being here today also. Thank you all.
Thank you. Thank you very much, Mr. David. Thank you for reminding us that particular incident still still drops tears here. So it's a good reminder that something can definitely go wrong in confined space. So it's not a place to just go to work anyhow without proper planning. So thank you for sharing that experience with us and with others to learn from. All right, the floor is open for other contributions before we call it a day. Any additional contribution before we call it a day?
Hello, yeah. Good evening, sir. Once again, it's Almojadi.
Good evening, Amojede. Go ahead.
Yes, can you hear me?
Yes, we can hear
So,
you.
it's a time topic. I just want to add a little addition. You've really done justice to the topic. You see, there is always a fire gas tester to be in that. You see, there are some gas. So if you can't whether there's so gas space, some people want to use their nose to check whether there's gas. There's no need to do that because there are some gases that are odorless, but they are poisonous. So it is very, very important that we carry out gas testing. This work during conference work. So long as there's a personnel inside that space, continuous gas testing should be done. And also, it's also important that we set our gas monitor on motion alert. Motion alert is a provision on the gas monitor that makes sure immobile. For example, if the employee is slumped in the cockpit, if there's employee, the gas monitor will detect and it will start beeping to raise an alarm. In the vicinity to know that is suffocating or dying. Continuous of hazardous gases, that may be respirators, with complete respirators in this field. Apart from that, man, for you must find a person that train the entrance and exit of if there is any issue. Then emergency to be in place. You cannot yourself you want to
Man, Amajede, I don't know why your network is always like that. I don't know why that network is always like that. Sir David, you want to speak? You can go ahead before Mojede connects back.
Okay. Good evening, you.
Good evening.
Even sorry, I was trying to skip the class, but however, of course, confined space cannot be overemphasized. I think yesterday, the day before yesterday, also it will be an advice and it's also be a question. And that was this week. This week we had a major incident at Saudi Arabia that claimed the life of 5 presidents. Now, though they're still doing the investigation, it was a gas line. It was a gas line. So I was trying to find out, was the gas not picked by portable gas monitoring? What could have caused it? Could it be the fault of the gas tester? Of course, gas tester can be faulty too if it is not properly calibrated. Then, secondly, I was told or I learned, so I just want to confirm it here, that in a confined space, for example, the lower explosive limit for methane and the upper explosive limit for methane between 5 down is too low that there cannot be fire incident. Then from to 15 above is too rich that there cannot be fire incident. But that ranging zone is where the problem is. My question is, can it be picked by gas monitoring at that range? Can gas monitor pick it that is a hazardous zone? That is the first question. The second one is confined space in an existing plant, that is brownfield, and confined space in a greenfield. Can they be tagged that they emanate the same hazard? So that is my question before contribution and other things, sir. Can you hear me, sir?
All right, thank you for your question. Yes, I heard you. The first one is that confined space in every location is the same. What is different is the substances or the type of hazardous substance available in any of them. So the definition of confined space says that any environment or any space that is difficult to enter, that has limited access and entry point, is a confined space. Any space that is not designed for continuous occupants is a confined space. Okay, so if it means those 3 criteria of a confined space definition, then it's a confined space. No, either in brownfield or in greenfield. The confined space definition is the same. Now, what is different is the types of hazard that is available in either of them. So one could have toxic gases available, one will not have toxic gases available. But one could have oxygen-enriched environment, then one could have oxygen-deficient environment. So these are just 2 different hazards, but the confined space definition and confined space is the same in both instances. Now, the question you asked about methane and the ppm, the exposure limit. So what happens is that depending on the industry and depending on the type of gas that they produce in large quantity, so they will have specialized monitors for each of these gas. So for large industries that produce large amount of methane, they don't specialize or they don't focus on using multiple gas detectors. So they will have specialized gas detectors that detect particularly methane. So, and the alarm or the alert will be set at a particular range that is required. So if we require a range of when the methane level is below combustible range, then that is when it will raise the alarm. If the alarm range was set at a space where that is above combustible range, then the alarm rate will be set there. But the major issue is that this range can be crossed in minutes or even in seconds. Okay, that is where the major issue is. So before the alarm could go off, or while the alarm is going off, it has exceeded the range that you considered normal before you entered. So if there is a pipe that has if there is a pipe break or a leakage somewhere, so it will not take minutes, it's less than seconds for this gas to spread across. And that the gas detector might detect it, but the response time is what is the problem. Maybe the gas detector has detected it, but it requires enough time for them to escape. And if they are not able to escape within that short time, then that is where the problem is. The problem is not always the gas detector detecting it, but the problem is always the response time. Because if the gas detector has detected it and you need to leave in seconds, how are you able to achieve that? That is the major problem, why it looks like the gas detectors are not doing their job. They are doing their job, but the response time, because we are humans, we are not a spirit that you will say that immediately the alarm has gone off, then you will disappear and come to the ground level. You need to take some steps. That is one of the major issues in response to gases.
Thank you, sir.
Yeah, with this, sir, before I was yanked off by the network, I was just trying to talk about emergency preparedness plan. So as I was trying to say that it's needful for emergency preparedness plan to be robust, and we plan ahead in safety. So then on coming online, I heard this little discussion that you guys were having. I just want to contribute a little bit of my own experience. You know, the new Alt 5X multi-gas monitor, we found out that it's able to really detect, because what happens is that that monitor, it has been set to be able to detect when the gas level goes down, because what is being given in the equipment is H2S, oxygen, carbon monoxide, and combustible gas. So you're going to find out that that detector picks any gas, and it has been set to detect gas within certain range. So if the gas is below, if the oxygen concentration is below the set value, it beeps. If the combustible gas is within the explosive limit, it beeps. So it is very important we say this here. These monitors, they are programmed in a way that that is able to pick any upset in the environment of work. And also, I just want to add on to your definition, sir. You know that an atmosphere may not contain a toxic gas per se, but generally we say an atmosphere is hazardous atmosphere, a gas may not be present, but there might be absence of oxygen, there might be oxygen enrichment causing various issues. So we say conditions that meet a confined space are: one, the presence of a hazardous atmosphere; two, limited means of exit and entry and exit; then also the presence of what a combustible what gas. So all those things they meet what hazardous atmosphere, and it's not also configured for continuous employee occupancy. So those are the four conditions that meet what a confined space. So if they meet these conditions, they qualify to be called a confined space, even if a gas is not present. If the atmosphere is hazardous, enrichment, what they call it now, oxygen deficiency, those are hazardous atmosphere. So those are what makes it confined. So that's my little contribution to what you guys were talking before I came in. Thank you.
Thank you very much, Omojede. Thank you for your wonderful contribution. The network tried to disrupt you, but you stayed put. So we really appreciate. So guys,
just to add one or two, sir. Just to add one or two, you know, this detector, the way it's the program is such the program in such a way that if you don't do recalibration on the detector, if you don't conduct your bump test, if you don't conduct your pump test, they are going to issues. So you using a gas, making sure that you conduct the necessary tests with the check gas monitors to be serviced, to be checked by the check gas, we conduct pump tests and bump tests on it, and also recalibration every now and then is very, very important. So that's my little contribution on that. Thank you very much.
Thank you, Omojede, for re-emphasizing that. It's very, very important. Conducting that bump test calibrations makes that gas monitoring machine, how would they put it? It makes it specific to your environment, because the gas monitoring machine can be used somewhere else, but for it to fit in specifically to your environment, you need to do that calibration, set your alarm, set your the point of detections, and make sure that it fits your environment. That is the major aim for that calibration and bump testing. Thank you very much for re-emphasizing that. Do you have any further contribution? Okay, I think that is all we have for today.
Okay, thank you very much, sir. However, Mr. Swangba is not here with us. So I don't know if he has reached you. So I just want to tell the house that he has left the project. He's on the is on the job search. So any available opportunity, please do well to contact him. It was due to it's a project demand. He was relieved of his job. That was 3 days ago because of project demand. Because the percentage of the projects has gone, we have gone about 80 or 90 something percent. So they are